Everybody, in this video what I want to do is a more complicated truth tree. It's the exact same problem I did in the last video with the truth table, so we should get the exact same result. It should be invalid, and we should have one particular counterexample. I believe in this one it's going to be when A is false, when B is true, and when C is false. But we're going to do this the tree method, which for a larger problem I actually think is much more efficient than doing it the table method. But on quiz 10 and quizzes 9 and 10 you're going to have to do both, but I recommend, like I said before, do quizzes 9 and 10 side by side. That way, if you see that, if you get on one of the quizzes that one is valid, but on the other one you get that a problem is invalid, you've done one of those wrong. It's always going to be consistent. If they're valid, it's going to be valid no matter what. If they're invalid, they're always going to have the precise same counterexamples. Well, let's do the tree method here. So what we do is we write out the premises with our conclusion on the bottom, and then the next thing to do, the way you begin a tree, is you are going to negate the conclusion. And in this case, the whole conclusion is B and C, so we don't just stick a not in front of the B, we got to negate the entire conclusion. Then what we do is we simply break things down by following this rough methodology here. If you can do a double negation, that is, you have a premise where there's two nots in the front, go ahead and simplify that down into, or double negate it into something as simple as possible. Then do the rules that stack. Those would basically be the rules that convert into a conjunction, and then break them apart. Those would be a negated conditional statement, a negated disjunction, and a regular conjunction. All of those would basically break down into two constituents and stack. We can't start with it. We have none of those things here, so we can't do that. Then we would move on to the rules that split, and then that would basically, they convert into a disjunction, and think of the splitting as just a giant disjunction in a diagram form. And those that split and stack, those that basically are a disjunction of conjunctions. They split and stack, and those would be the rules with biconditionals and exclusive disjunctions. Well, let's start by seeing what we can break down. I'm going to go ahead and say not A cannot be broken down anymore, so I'm going to go ahead and check it off. We're never going to get anything simpler than not A. Then what we see, I like to work my way up the trunk, so starting with the simplest stuff first. No double negations, nothing that can stack. The first thing, all three of these are going to split. I have a negated conjunction, a conditional, and an inclusive disjunction. All of those are going to split. So in one sense, it really doesn't matter which one I do first, but I'm going to start from the bottom and work my way up. Not B and C, that's a negated conjunction. If you look at the tree rule for that, what it does is it splits, and basically whatever is inside the negated conjunction, it turns into not the left and not the right. So we get not B, not C. Again, it's just a Morgan's law. If you look at not B and C, that would turn that into an or, you would get not B or not C. That's what it does. This is broken down, and then what we do after we do every breakdown is we see, do we have in whatever branches or tributaries or circuits, however you want to call them, do we have any contradictions in the circuit? Nope. Nope. Moving on. Next, that's been broken down. That can't be broken down anymore. Next one is C arrow A. That's also a split rule, and if you go back and look at disjunctive implication, we're going to turn this arrow into an or basically. That would mean all we do is we negate the left. So C arrow A is the same thing as not C or A, but because we have multiple branches now, this has to flow down into this, and this has to flow down into this. So we have to put it on. Anything that's still open, so we have these two places here, anything that we do higher up is going to flow down both routes. Okay, just like if you think of a triangular roof, and you pour water on the top, it's going to flow on both sides. The exact same principle here, even though we're dealing with it in a diagram form. That's been broken down. Now what we're going to do is see in these splits, do we have any contradictions? Do we have any sets of opposites up in the circuit or tributary or branch, depending on what you call them? Nope. Yes, look, A, not A. So this closes. This one's done. This one's not leaking anymore. This one. Nope, nothing. This one, yep, A, not A. This one's closed off. So these are the two open ones right now. Not everything hasn't been broken down yet. These are the two open ones right now. So anything that we break down is going to flow still out through these two. This one here, this one that has a not C, and this one not here. That also is a not C. We have an inclusive disjunction here. the way that's a split rule, and what it does is it splits, and since you're turning an OR into an OR, nothing changes in terms of negations. So what does that do? That gives us A XOR B and C, and then it flows onto this one too. We get A XOR B and C. So what we want to do now is just double check and make sure, see if we have any contradictions in our now 4 tributaries that we need to worry about. Nope. Yep, right there. C, not C, so that one closes. Here? No, at least not yet. Here? C and not C again. So now we have these 2 branches to deal with. They're still open, but nothing needs to be broken down from higher up. So there's nothing left that could break down and flow into this stuff. If this breaks down more, it would only flow from here. If this breaks down more, which they both do, it would flow down only from here, even though they're identical things. So we have an XOR. XORs are ones that split and stack. So think about it. If I have A or B but not both, that's like saying I have one of 2 scenarios. I have a scenario where A works but B does not, or I have a scenario where A does not work and B does. That breaks down here. Now what I want to do now is see in this branch, do I have any contradictions? Yep, A and not A all the way up here, and here, and this one, B and not B. So this can't be broken down anymore. This all closes off. So the only thing left to deal with is this right here. Now we know, again, from doing it in a table form that it's going to be invalid, but let's see if we can confirm it. So what does this break down into? It breaks down, it's the same kind of thing here, this is just on its own. It breaks down to the same stuff, A XOR B, breaks down into a scenario where A would be true and B is not, or it would break down into a scenario where A is not true but B is. Now let's go up the stack. Do we have in this tributary any contradictions? Yep, or contraries. A, not A way at the top. What about this one? No contradictions. So this branch is open. It's open, and that means that the argument is invalid. Of course, we knew that it would be. We're doing it in the table method. But also, this way gets us the counterexample as well. So we look at the simple constituents, A, B, and C, and look and see, are they positive or negative in every instance that we see them in this particular branch. So let's look at A first. Here's A. We see it's not A and not A. Every time we see it, it's not A. What do we see with B every single time we see it? Is it B or not B? In this particular circuit, every time that it's broken down. B, that's the only time we see it. Let's take a look at C every time we see it. Not C, not C, not C. So, not only is the argument invalid, we know from doing the tree, but also we have the counterexample. When A is false, B is true, and when C is false, it will not work. Another way of writing that, of course, would be ABC. We could say when A is false, when B is true, when C is false. It does not work. That is exactly what we got by the table method as well. This is the tree method. I think this is a little bit more efficient. Excuse me. Again, look at the tree rules that you have in front of you and just apply them like this. Anything that you break down, make sure it's flowing anywhere you have anything open downstream.